Humans have always been explorers, driven by an insatiable curiosity and a desire to understand the unknown. We crossed vast oceans before we even had the technology to build sophisticated ships, relying on the stars and our instincts. We ventured into dense, uncharted jungles long before we had accurate maps to guide us, driven by the spirit of adventure. It's in our blood to push the boundaries, to see what's over the horizon, to seek out new frontiers and expand our understanding of the world and beyond. Today that horizon lies on Mars, the mysterious red planet that has captured our imagination for generations. The red planet beckons us with the promise of discovery, the allure of the unknown, and the challenge of survival in a harsh alien environment. It represents the next giant leap for humanity, a chance to establish a new home among the stars, to build a future that extends beyond Earth. But Mars will not be easily tamed. Its harsh weather, brutal storms, and unforgiving terrain present formidable challenges. It presents challenges unlike anything we've faced before, testing our ingenuity, resilience, and determination. This is not a mission for the faint of heart. It requires courage, preparation, and an unwavering commitment to the pursuit of knowledge. This is a mission for pioneers, for those who yearn to write the next chapter in human history, to leave a legacy of exploration and discovery. This is about building a future on Mars, and it starts with confronting the formidable obstacles in our path, overcoming them, and laying the foundation for a new era of human achievement. The first thing you notice about Mars is the sky. It's not the brilliant blue we're used to on Earth. Instead, it's a pale, washed-out pink, a constant reminder of the thin, unbreathable atmosphere. This thin atmosphere poses a major challenge for human survival. On Earth, we take our air for granted. We breathe without a second thought. On Mars, every breath will be a precious commodity. The Martian atmosphere is about 1% the density of Earth's, composed mostly of carbon dioxide, with trace amounts of nitrogen and argon. This means we need pressurized habitats just to walk around outside. It means we need to manufacture our own breathable air, either by extracting oxygen from Martian resources or by shipping it from Earth, a costly and inefficient process. If the thin atmosphere doesn't get you, the temperature swings will. Mars is much colder than Earth, with an average surface temperature of about -80 degrees Fahrenheit. But it's not the average that's the problem, it's the extremes. At the equator, temperatures can reach a balmy 70 degrees Fahrenheit during the day. Sounds pleasant, right? But wait until the sun dips below the horizon. That's when the mercury plummets, dropping to a frigid -200 degrees Fahrenheit at night. These wild fluctuations make designing habitats a nightmare. They need to withstand both extreme cold and occasional heat, all while maintaining a comfortable internal temperature for human occupants. It's like building a house that can survive both a blizzard and a blast furnace. And as if the cold and the thin air weren't enough, Mars likes to throw in a curveball dust storms. These storms are not just minor inconveniences. They are colossal events that can dramatically alter the Martian landscape. These aren't your average dust devils, mind you. They can grow to be massive, towering columns of dust that stretch miles into the sky, swirling with an intensity that can be both mesmerizing and terrifying. These storms can engulf the entire planet, blanketing it in a thick haze of red dust for months on end. The sheer scale of these storms is mind-boggling, turning day into night and making navigation nearly impossible. Imagine the sun, a dull red dot barely visible through the swirling dust. The once bright and clear Martian sky becomes a murky, ominous red, casting an eerie glow over the landscape. Solar panels, our lifeline for power, become useless. The thick layer of dust that settles on them blocks out the sunlight, cutting off our primary source of energy. Communication with Earth is cut off. The dust interferes with radio signals, making it difficult to send and receive messages, leaving us isolated and vulnerable. The Martian surface becomes a hostile, alien world once again. The familiar landmarks are obscured, and the environment becomes even more treacherous. These storms are a constant threat, and we need to be prepared. Advanced warning systems and robust infrastructure are essential to withstand these powerful natural events. Habitats need to be sealed tight against the fine, abrasive dust. The dust can infiltrate even the smallest cracks, causing damage to equipment and posing health risks to inhabitants. We need backup power systems in case our solar panels get choked. Alternative energy sources such as nuclear or wind power could provide the necessary resilience. and we need to develop reliable communication systems that can pierce through the dust storms. Innovations in technology will be crucial to maintaining contact with Earth and ensuring the safety of those on Mars. Water is essential for life as we know it. It's crucial for drinking, for growing food, and for producing breathable oxygen. Luckily, there is evidence of water on Mars, but it's not exactly readily available. Scientists believe that vast reserves of water ice exist beneath the Martian surface, locked away in the permafrost. There's also evidence of liquid water flowing on the surface during warmer seasons, but these are briny, salty flows, not the kind you'd want to drink straight from. Extracting and purifying this water will be a major challenge. We'll need to develop innovative technologies to drill deep into the Martian soil, extract the ice, and purify it for human consumption. Every drop will be precious and recycling will be essential. Here on Earth, we're shielded from harmful cosmic radiation by our planet's magnetic field and thick atmosphere. Mars, unfortunately, has neither. This means that the surface is bombarded with radiation constantly, posing a serious health risk to astronauts. Long-term exposure to radiation can increase the risk of cancer and other health problems. We'll need to develop effective shielding for habitats and vehicles, perhaps by using Martian regolith, the loose soil and rock on the surface. The Martian soil itself presents another challenge. It's toxic to humans, containing high levels of perchlorates, which can interfere with thyroid function. We'll need to develop ways to either remove these toxins from the soil or find ways to grow food in protected environments. Let's not forget the human factor. Living on Mars will be the ultimate test of human resilience. Imagine spending months, maybe years, confined in a small habitat, millions of miles from home, with the same small group of people, 24/7. The isolation, the confinement, the constant danger, it will take a toll on even the most well-adjusted individuals. We need to select astronauts not just for their technical skills, but also for their psychological strength. We'll need to develop new strategies for maintaining mental health in space. Virtual reality, telemedicine, and other technologies can help bridge the distance and provide astronauts with a connection to Earth and the support they need to thrive in this challenging environment. Section 8. A million moving parts a million miles away. Getting to Mars is hard enough, but once we're there, the real challenge begins: building a base that can sustain human life. This means transporting massive amounts of equipment, supplies, and materials across millions of miles of space. Traditional rockets, while powerful, are expensive and inefficient for this kind of sustained operation. We need to develop new propulsion systems such as nuclear, thermal, or ion propulsion that can shorten travel times and reduce the cost of transporting cargo to Mars. We'll also need to master the art of in-situ resource utilization, or ISRU. This means using resources found on Mars to create what we need, rather than relying solely on supplies from Earth. Think of it as Martian recycling on a grand scale. Section 9. 3D printing with Martian dust. One of the most promising technologies for ISRU is 3D printing. Imagine using Martian regolith, the loose soil and rock found everywhere, as a building material. 3D printers could use this readily available resource to construct habitats, landing pads, even roads. This would drastically reduce the amount of material we need to ship from Earth, making missions to Mars more sustainable and affordable. It would also give us the flexibility to adapt and expand our base as needed, using local resources. This technology is already being tested on Earth, and the potential applications for Mars are vast. Imagine printing custom tools, replacement parts, even medical devices on demand using nothing but Martian dust. Section 10. Growing food under glass. We can't live on freeze-dried food forever. To establish a permanent presence on Mars, we need to grow our own food. This means creating greenhouses, protected from the harsh environment, where we can cultivate crops. Hydroponics and aeroponics, methods of growing plants without soil, will be crucial. These systems use water and nutrient solutions to deliver essential nutrients to plants, while LED lighting provides the energy for photosynthesis. Imagine biting into a fresh Martian tomato, grown in a high-tech greenhouse powered by the sun. It's not just about sustenance, it's about bringing a touch of Earth and a sense of normalcy to a truly alien world. Section 11. A leap into the future. Building a Mars base will be hard, dangerously hard, insanely hard. The challenges are immense, from the hostile environment to the sheer distance from Earth. Every step will be fraught with difficulties, and every success will be hard-won. But it will be the most important thing humanity has ever done. Establishing a foothold on another planet will mark a new era in human history, a testament to our ingenuity and determination. It will push the boundaries of science, technology, and the human spirit. The innovations required to survive and thrive on Mars will drive advancements in fields we can only begin to imagine. It will force us to innovate and collaborate like never before. Nations will come together, pooling resources and knowledge, united by a common goal. And in overcoming these challenges, we will learn more about ourselves, about our place in the universe, than we ever could have imagined. The journey to Mars will be a journey of self-discovery for all of humanity. We will develop technologies that benefit not just space exploration, but also life here on Earth. These advancements will have far-reaching impacts, improving our daily lives and addressing some of our most pressing problems. This is not about escaping Earth's problems. It's about finding solutions that can help us here and now, while also preparing for the future. This is about ensuring humanity's future. By expanding our horizons, we secure a better tomorrow for generations to come. It's about becoming a multi-planetary species, a safeguard against any single event that might threaten our existence on this planet. Diversifying our presence in the cosmos is a form of insurance for humanity. It's about reaching for the stars and taking the next giant leap for humankind. This endeavor will inspire future generations to dream bigger, aim higher, and achieve the impossible.